Okay, for this set of examples, we're going to do one more complicated one and then start looking at the trig functions. So we'll start with g of x equals 3x cubed minus 2x plus 3, and we'll divide that by the square root of x. So you can do this problem in one of two ways. You can do it the way I did it the first time on the last video, which was divide everything by the square root of x, or you can bring the square root of x up. So this square root of x is really an x to the 1/2. So you could write this as 3x cubed divide by x to the 1/2 minus 2x divide by x to the 1/2 plus 3 over x to the 1/2. So I can divide it like that or bring it up to be an x to the negative 1/2 in the numerator. Either one of those will work just fine. So then what I'm going to do is actually simplify. You can either multiply this in and add the exponents, or you can divide and subtract the exponents. So I'm going to subtract. So this will be a 3x. Then I have 3 minus 1/2. So that's really 6 halves take away 1/2, and it's 5 halves. This is an x to the first. 1 minus 1/2 is just 1/2. And then this would be a plus 3x to the negative 1/2. So now I'm going to take the derivative, multiply down. So this will be 15 halves x to the, and then you subtract 1, so minus 2 halves, so it's to the 3 halves. Multiply down again, minus 1x, subtract 1 is negative 1/2, plus 3, times the negative 1/2, so minus 3 halves, x, and then I'm going to subtract 2 halves here to the negative 3 halves. Okay, I need to rewrite this. So g prime of x will equal 15, it's x to the third with the square root over 2, minus 1 over the square root of x to the first, minus 3 over 2, then this is x cubed with the square root. So that's a pretty complicated looking derivative. The next problem is y equals, and let's just start doing some trig. So we have sine x over 2. That's also 1/2 sine x. And we know the derivative of sine x is cosine x, so these are very simple replacements. Y prime equals 1/2 cosine x, and that problem is finished. If you look at the next one, what if you have a combination? So y equals x plus cosine x plus 7. You just do the derivative term by term. So y prime equals the derivative of x is 1. The derivative of cosine x is negative sine x. It starts with a c. It'll have a negative derivative. And the derivative of 7, a constant, is 0. So this is your derivative. For the next problem, what if you have something multiplied? So y equals 2 sine x. That'll be the same thing. Just keep it as y prime equals 2 cosine x. And it's easy. If you have something like y equals 3 plus 4 tangent x, your answer would be y prime equals 3 is a constant. I leave my 4 in there. The derivative of tangent x is secant squared x, and that problem is done. So some people think the trig functions are hard, but if you actually know what the derivatives are, they're very easy. So we've got 2 more to look at. Let's say we have y equals negative cosecant x plus 5x squared. Then my y prime will be the opposite of whatever this is. So I'm going to say it's the opposite, and then the derivative of cosecant x, it starts with a c, so it's negative. I know the derivative of secant x is secant x tangent x, so cosecant x will be cosecant x cotangent x. And then the derivative of 5x squared is 10x to the first. So y prime equals a positive cosecant x cotangent x plus 10x. And that is finished. Last one, something simple, y equals 5 secant x minus 7 cosine x. And again, we're just replacing. So y prime will equal 5 times the derivative of secant x, so that's secant x tangent x, minus 7 times the derivative of cosine x. This starts with a c, so the derivative is negative, so it'll make it a positive sine x. And that should probably be actually too many examples to get you all started.